I'm Thor. I'm an engineering intern here at Mitotec Precision. I go to school for mechanical and manufacturing engineering. It's a double major offered by UW-Stout. And recently we've been working on a new project using a UR robot, a Cobot, to help us in our assembly. It's hard to find workers these days, so if we can get these Cobots in place, we can maximize the potential of our current workers. That is where the big win is for us. We chose this process of engraving the parts due to its kind of mundane nature. The first task was getting the robot to load and unload the laser, and then we were just having a human checking the parts and making sure everything was good, making sure everything was working as it should. It's a 3-minute cycle for that laser to finish the engraving on the part. By having the robot do this, we can use the employees to their full potential and kind of increase the efficiency of that work area. There's essentially no downtime. Yeah, the biggest thing is focusing on not replacing jobs, but just helping jobs. Some of the problems we've been having with this robot, or that we did have, was opening that door. To start, it was just a door on a hinge, and it was possible to have the robot open it, but it didn't do it well. And so now we've proved that out, and that worked well. So we were moving forward with the project. We've installed a new door that allows the robot to open and close it easily through the use of a pneumatic actuator. It fires a piston that shuts the door and then also locks the part into place. Designing my own solutions to some of these problems that we've had, designing that pneumatic door and the way to locate it, and I've had a lot of help with that from the other engineers here on staff, but that's been a pretty good project for what I'm studying. It's been just kind of a steady, kind of like a checklist. You get one thing and then you move to the next problem with this. It's been, get that door to work. Okay, the door's working. Now how do we locate the robot into that spot so it can't move? Getting that located to the same spot each time so that someone could unload that entire pallet or pick it up, move it, use it for another process, bring it back and have it in the exact same spot. So we solved this issue through the use of 3 locating pins, 2 on one side and 1 on the other of the pallet, and then a linear tab locks the plate into place so it's in the same position every single time. Sometimes you get one thing done and then you move back down 3 steps because it altered a previous process. This whole process has been kind of like one of our sayings here at Mitotec: the challenge of the complex and the satisfaction of the solution. This project really helped me to grow as a mechanical and manufacturing engineer, as a student. The benefit I got from this was where I was able to see how the parts are flowing through and how automating this process could help that part flow and help the assembly be faster and more efficient. When the laser is completed, the robot opens the door, takes the part out, and then brings it over to our camera where it is checked if it's engraved correctly. The camera is checking for the size of the engraving and the position of the engraving on the part. The camera is also taking an image of each part and storing it into a file so that it can be reviewed later if there was any need to. One other battle we've had is learning the new program. It was quite complicated and it was a bit of a steep learning curve. Through a lot of research, I was able to kind of figure it out on my own, and talking with some of the other engineers here on staff, it was able to help me work my way through it. And then again, on the camera, getting the communications from the camera to the robot was a bit of a battle. The camera communicates with a wired connection to the robot for inputs and outputs. And getting those inputs and outputs wired up into the robot, I had never done that before, and through some of that research in the camera, I found wiring diagrams and was able to successfully complete that. Another problem we had was getting a good image from the camera. This camera is pretty finicky on the conditions to make sure that it gets a good contrast and can see the part. And with these parts being an engraved text on a round surface that's also shiny because it's titanium, it was quite difficult to get a good image. To kind of combat that, we made a hood that fits around the camera. This way it's darker and the flash of the camera can get a better picture, can get more contrast from the part. When that part passes those inspections, it's stored onto a 25-part pallet. The operator is in charge of loading the robot every 7 parts. When the feed of the robot is empty, they have to come over, load 7 more in, and then start them to go again. And then also there's a 1 in 10 check on these parts, so every 10 parts the robot will set an alarm off or set a light off that allows the operator to see they need to come over and give it a little attention, get it going again. What I enjoyed most about working on this project with the Cobot and this camera, it's the sense of accomplishment of figuring it out and kind of battling through it. There's been a lot of frustrations, a lot of problems, and it kind of always seemed like nothing ever went right the first try. But when everything kind of came together now at the end and we have a fairly successful solution, it just feels really good to finally see it working. Getting everything to work together has been a pretty complex process, but when we finally see it working, we finally see this robot making parts, there's nothing quite like it.